Hi, everybody. This is Dean Smith from the Community of Human and Organizational Learning, and I am letting people in from the waiting room. So this is a very slow way to let people make that transition. And once I'm sure we have everybody in, which it looks like we do, welcome. Welcome to today's webinar. I'm thrilled to have Scott Griffith, the founder and managing partner from SG Collaborative Solutions. I think you've all read Scott's awesome in-depth bio in the webinar introduction that you saw. Scott is going to talk to us, or talk with us, I should say, about collaborative high reliability. And the thing that really intrigues me about Scott, and Scott, I'm sorry, I'm going to gush a little bit, is the wide background in terms of different industries that you've touched and the depth at which you've touched them. And then the other thing that Scott and I talked about in advance of this webinar is the thinking about how to build that kind of collaborative culture across organizational silos. And that's me paraphrasing Scott. So if I paraphrased it in an incorrect way, I apologize, but directionally, I think that's where we're going today. So Scott, I will turn it over to you. It's great to see you.
Thank you, Dean. Thanks everyone for having me. It's a pleasure. As he mentioned, I have worked in a number of industries. And Dean, I attribute that to occupational ADD. I tend to love working in different venues. So today we have a pretty good turnout. I'm really impressed. I know. Now, how are we able to do? You're able to see the chats, right?
Yeah. So please, everybody, throughout the discussion, the conversation today, feel free to jump in with questions or chat them into the chat box, and I'll keep an eye on that, Scott.
Great. So many of you, I feel like I know many of you. I've seen you at, I think I've presented now, this will be my third, maybe fourth conference. And I had just gotten used to the acronym HPRCT. And now I have to learn a whole new one, CHOL, Community of Human and Organizational Learning. Is that correct, Dean?
That is correct.
And I understand there's been a little bit of a refocusing, and I think it's highly appropriate. What we're going to talk about today, I consider us all to be in the same community. I started, I think the last time we presented pre-COVID in the Colorado Springs conference, now 3 years ago, right? Coming up on 3 years ago. I asked a question of the audience, and I said, how many of you are safety professionals, consider yourself involved in the safety community? And a large majority of people raised their hands. And I said, well, then how many of you are operational? That is, you work in your specific industry, not in a safety capacity, but you have operational responsibilities. And several more raised their hand. And then I asked the question, how many of you are human resource specialists or professionals? And I can't recall a single person that raised their hand. Maybe one, maybe two out of a couple of hundred or more. And what I would encourage you to do if you are attending the conference is give some consideration to bringing your counterparts in the HR community, because as we talk about human and organizational learning, we're obviously going to be dealing with performance and human behaviors, and we want to include those individuals in your organization that have HR responsibilities. And because you've heard the term, we tend to congregate in silos or tribes, and I think that's all well and good, but I also think there's a place here where we come together as a community and we use our cross-disciplinary expertise, and that obviously will include HR. So what I'm going to describe today is a new term called collaborative high reliability, and along with that comes the term collaborative just culture. And Dean came up with this amazing title, and I apologize, Dean, I didn't put the exact title on this slide because I was rushing today. I can explain afterward why I was a little bit late to the webinar today, but the term collaborative has a specific meaning that I will explain, and so we've added the term to high reliability, and hopefully that'll inspire you to ask some questions, and we'll engage in some conversations. So I'm going to be bold here, and I love this sort of Star Trek image of the Earth. We believe that this is the world's first high reliability certification by an independent audit organization. Now, you may correct me, and if so, then I will stand corrected. But to our knowledge, this is the world's first high reliability certification by an independent audit organization, and I will explain that. It's a group called DNV. DNV is a global consortium. It's a Danish, German, Norwegian collaboration. And we started working with the USA Healthcare Division and expanded our reach into other aspects of DNV. But they are the independent body. DNV uses the ISO 9001 methodology. They are a quality management based auditing organization, and I will give you some detail about their work. And I've also proposed that our next webinar coming in April, they've agreed, Dean, to come in, DNV to come in and lay out their audit program for those of you that may be interested down the road. So I think you'll find that fascinating, and it'll certainly tie into what I'm going to describe today. But what I'm going to do is I'm going to describe a little bit of the history of our model. We call it collaborative high reliability. And I'll share with you how we arrived at that and some of the details of it and why we believe it to be evidence-based. Okay, so my company is called SG Collaborative Solutions. We work in a number of high consequence industries, including the energy sectors, aviation, rail, law enforcement, EMS, acute care hospitals. We've worked across a broad array of organizations. And we're the authors of something that I call the sequence of reliability. I will describe that. And it's partly, I think, the reason why Dean helped me come up with the title of a logical way to achieve just culture and high reliability. So Dean, what was the exact title? Forgive me for not knowing it. What was the title of this talk today?
It was the logical, measured way to, boy, Scott, you know what? I don't even remember. It was something brilliant, I must say. It was the logical, measured way to build a high reliability and just culture, something yes, to that effect.
So if I'd had more time, I would have put an image of Spock, from Star Trek on here, because I'm going to show you what we call the sequence of reliability in just a few moments. I'm a little bit embarrassed because when I show it, it is so simple. In fact, I think I mentioned it at the conference a few years ago that I was in college one time and a professor made a comment after I had said something in class that I seemed to have an intuitive grasp of the obvious. And I thought that was a compliment, and then I thought about it a moment. I thought, well, he kind of insulted me. But when I show you the sequence of reliability, which I believe to be so elemental and simple, you're going to say, well, Scott, this is intuitively obvious. And then I'm going to reply back, well, show me an organization that does it this way using this method. And we'll both be challenged, I think, to come up with clear examples of how that happens. But I'm going to show it to you in just a moment. Now, DNV, again, the healthcare division works primarily in the USA, but the parent company works worldwide. I will give you a little more detail about DNV at the end of the presentation, and hopefully you'll be interested in coming back next month for a webinar that DNV will provide. Okay, so I'm going to break this down into the why, the what, and the how. And you may have heard Simon Sinek speak, or read some of his books, or seen him on a TED Talk or YouTube video. But Simon Sinek says that if you don't address the why, nothing else matters. I can describe the most elegant, beautiful approach there is to high reliability and just culture, but if you and your organization aren't motivated, if you don't get the why, then the what and the how won't make much of a difference. Now, I can debate that, but I think it is very important as you look to your organization to see whether or not the organization is truly motivated. And I'm going to describe that in just one slide, but then I'm going to jump into what I call the model, the sequence of reliability, and then the collaborative high reliability model itself. And then I'll go in and touch on how we have teamed up with DNV as the independent auditing group, and I'll share with you, a little bit of their methodology as a precursor to their webinar next month. So I just listed uh, several of the reasons we typically hear with those organizations we work with that says, well, why would you want to engage in this work? Now, I'm not talking about safety professionals. I'm talking about the organization at large. And as you know, safety departments, and I used to be, chief safety officer at American Airlines, and I can tell you, the chief safety officer at American Airlines never ran the airline. We never made decisions relative to the business model. We were always there to help preserve assets and prevent plane crashes and injuries and all of those important measures. But the business leaders that lead any organization have to be motivated and understand the advantages of doing this work. And so some of the things we typically hear are an organizational desire to improve across all values. And I'll speak to values in just a moment. To prevent failures and adverse events. So clearly, there are some activities that are so high consequence that if you were to have a plane crash or a meltdown, it would be catastrophic. So you would have, tens and hundreds of millions of dollars in assets at risk and lives. So that's one motivation. Optimizing your assets and resources to improve your bottom line is always a motivator. Many organizations are concerned about cultural cohesiveness, getting people to be pulling in the right direction, ways to gain competitive advantages. If you're in a business that competes for customers, sometimes high reliability will give you that advantage that will give you an edge to acquire those customers. Ensuring long-term sustainability for the business, and then the last one, which I think is my favorite, which is when a CEO and the C-suite just engages in this work because they believe it to be the right thing to do. Those are the ones that we most often love to work with. So I'm going to share. I'm going to stop the why, and I'm going to ask you, what would motivate you? And when I mean you, I mean the collective you. What would motivate you and your organization to engage in this work? And let me just stop and take a moment here, because I don't want to presuppose that everybody here is in organizations that are committed to high reliability. So, Dean, I'd like to hear from the group, either chat or if you want to come off video or come on video and just ask a question. Let me know what would motivate your organization to engage in high reliability work.
Yeah, great. Thank you, Scott. And I'll take a look at the chat box, but please, everybody, feel free to unmute yourselves and just jump in and offer an insight or two, or chat your thoughts about that into the chat box. Yeah, Scott, and I agree with you. The last one is probably the most powerful, but, a difficult one to wrap your head around.
That's right. That's right. And we're going to talk about, well, okay, so it's the right thing to do. So is mom and apple pie. But
yeah,
what does that mean? One of the questions that I think we find ourselves asking a lot is, what's our 90-second elevator speech? If you're caught in the elevator with your CEO or someone on your board, what's the pitch? What are you going to say to that person, him or her, that's going to get their attention to say, well, what is high reliability? What's the advantage for us?
And while we're waiting for people to chat into the chat box, Bob Latino has posed an interesting question in there, Scott, that, what's the difference between what is perceived as traditional reliability versus HRO?
Oh boy, Bob. Oh boy. I can only say, oh boy. I'm going to talk about traditional views of HRO. And what we're going to present to you is a model that we believe steps a couple of steps beyond the academic literature, what's typically understood as HR. And so let's ask that question here about what is an HRO and who are they? Give me some examples of an HRO. Highly reliable organization. Well,
I'll ask everybody. Just jump right in. Let's. I want to engage the audience here, Scott. And I'm building on your question. So everybody, please just type some thoughts into that chat box or unmute yourselves. And we're starting to get some. Morgan talked about industry, nuclear industry. Jake added flight deck crews of aircraft carriers. Tanya, same thing.
Right. Okay, so that's what we typically hear, and I have a whole nother presentation that I'm not going to share today because I was going to jump right into the model, which I will do here in just a moment. But what we typically hear now, one of the industries that I work quite a lot in is healthcare, and healthcare is notable in that they try to achieve success in a lot of ways through emulation. They take success stories in certain industries like aviation and the use of checklist, Lean Six Sigma, which came out of the manufacturing industries, and Toyota as one of the leaders in quality. They point to aircraft carriers. And so I'll go into a hospital and they'll say, oh, yeah, I know people that actually have made the trip to Japan to bow at the altar of Edwards Deming and sit down and learn the Toyota methodology. And they come back to hospitals. And I was speaking to one hospital COO, and I told her, I said, well, okay, so you saw a production line, yes, and you saw a cord where anyone on the production line could stop the line. They call it stop the line by pulling the cord. I said, show me where that cord is in your hospital. And she looked at me and said, what do you mean? I said, well, you learned all of the methodologies. Let's just take that one element where every employee is empowered to stop the line. Show me where that cord is in the hospital. And of course, she couldn't do it. And it's like, well, it's a metaphor. I said, well, yeah, a lot of things we describe are metaphors. But let's be specific on why the cord works in the automobile manufacturing industry, stopping the line. When you have a production where you have equipment moving in a linear fashion and employees being the quality control of that line, it makes sense to have a button to stop it, or if someone is going to be injured, perhaps they have something caught in a conveyor belt. All of those are engineering design features. The problem is that in the nuclear industry or in the energy sectors and clearly in aviation and manufacturing, it's filled with engineers who understand engineering principles. When you move into healthcare, where the dominant science in healthcare is not the engineering sciences, it's medical science. And medical science has evolved in a very different way than the engineering and aviation sciences. So when I go speak to a COO in healthcare, rarely do you see someone that understands the principles of barriers, redundancies, and recovery features, which are just classic engineering terms. They understand the language of business or they understand the science of medicine, but it's a very different approach. So I guess my point is that when you take something from one industry and stick it into another, expecting the same or similar results, you're more than often going to be disappointed, which is exactly what we've seen in healthcare, where they've tried to emulate some of these other successes that they've seen in other industries. So the use of checklists, for example. Aviation is filled with a rigorous application of the use of checklists, from the cockpit to the maintenance setting to the design features of an aircraft. You put that same checklist or a similar checklist into a surgical suite where the doctor may not be employed by the hospital and they're never trained together in the same environment. They don't know the difference between a challenge response and a challenge due response checklist. They're just using a tool without the proper background and training and understanding of why it works. And then you put it in an environment where a patient goes into a code, and now all of that expectation may not give you the result you're expecting. So if the literature shows that the initial successes of checklist in the OR achieved some modest success, but that success has been difficult to replicate in hospitals across the country because it's in a very different environment. So it's a rather long-winded way of saying, if we're going to point to an aircraft carrier or a nuclear power plant or an airline or manufacturer, let's be very careful, because in each of those examples that I just gave, I can give you examples where catastrophes occurred. You look at the Fukushima plant in Japan, where the tsunami and earthquake came in and penetrated the barrier, causing some leakage. We could go into the details, but the point is that all the design in-depth features in that were not enough to withstand the catastrophic effect of the environment. You can look at aviation, which has achieved enormous success over the past 20 years. And I'm going to go into a little more detail of that here in just a second. But I can show you, we just had a plane crash here in China here this week. So being in a highly reliable, or an industry that's considered highly reliable, doesn't mean that the specific organization is highly reliable. And we're going to go into, well, you can be highly reliable today, and tomorrow, for a variety of reasons, you can be less reliable, even unreliable. And I'm going to explain that in more detail. So I guess we're starting out. Let's agree that we have work to do to define what highly reliable means. And now we're going to address that question, and we're going to go into why we believe this particular model gives you a pathway to get to that. Okay, so I'll advance the slide if I can get my computer to work here. Okay, so now we're going to move into the what, and I'm going to give you the sequence of reliability, show you the model. We'll take a few more questions after that, and then we'll jump into how the audit process works. Now, all of this, it's a shameless plug for a book manuscript that I've written. We've not sold it to a publisher yet because my agent and I decided we were going to put everything on hold during COVID, and then we got distracted. We're going to go back to this, so we expect it to be published officially sometime next year. If you'd like a preliminary copy of the book in PDF form, I'd be happy to provide it. So when we talk about high reliability, we're going to go back to what I consider to be first principles. And the physicist in me says that everything can evolve from basic understanding of first principles. So we're going to define high reliability as sustained high performance over time. Now, this is kind of a simple little diagram, but it's meant to show that sustainably high reliable organizations will continuously improve. You've heard that term before, continuous improvement. But more than that, we're going to go into the ways in which you can ensure that your performance is sustained over time. And I'm going to get into the science of this in some kind of geeky ways. All right, so without further ado, I'm going to introduce you to the sequence of reliability. And along the way, I'm going to tell a story. So you may have heard me tell this story if you were present in Colorado Springs 3 years ago, but I'm going to tell it again because it's where this started. 1985, August 2nd of 1985, I was a young pilot doing a walk-around inspection on a Boeing 727 at terminal. At the time, it was called 2E. It's since been relabeled. But I was walking around gate number 12 in terminal 2E, and I looked up in the sky to the north, and there was a Lockheed Delta 11 coming in to land on the outboard runway, and the plane got precariously low. The plane was in distress. So like most pilots, I talk with my hands, and you'll see me, making pictures of airplanes with my hand. So the plane came in and struck a building, bounced up, and I thought, oh my gosh, it looks like the plane may make the runway, maybe not, I don't know. I was watching it, and it bounced on top of a car on Highway 114 just to the north, and killed the occupant. I learned later. And I thought, well, it might make the runway. Maybe it's going to land a little bit short. But unfortunately, the left wing struck an above ground water tank, 2 water tanks, and the airplane cartwheeled, burst into flames. The rest is aviation history. You may recall the cause of that crash, or if you're too young to remember, I'll tell you. It was caused by, or initiated by, a microburst, a wind shear microburst. Now, the pilots coming in to land on that afternoon, typical late summer day in August at DFW, you expect to see cumulonimbus clouds in the horizon, moderate rain showers, no big deal. We live in an area known as Thunderstorm Alley. Well, we'd been flying around thunderstorms for over 100 years. Well, at that time, actually about 75 years. But the plane came in, and what the plane saw on radar was off to the west, to their, I guess, the right-hand side of the aircraft as they were landing south, was a rain shower coming out underneath the cloud. No problem. Rain rarely, if ever, could bring an airplane down. In fact, we don't know of a plane on record that crashed solely because of rain. Rain wasn't the threat that day. What was the threat was something that was invisible, which was a wind field that had a column of air that comes down in a vertical shaft, and then when it strikes the ground, it curls up into these vortices. Now, this is shown to be symmetric, and they're not typically symmetric depending on the direction of the flow. But at the time, the term microburst had just only been suggested by a man named Theodore Fujita, who was a meteorologist physicist in Denver, Colorado. Well, interestingly enough, post-accident, I ended up leaving the airline on a leave of absence and working on a project for NASA for 2 years, where I teamed up with Dr. Fujita, and I worked on a project to develop a laser onboard system known as LiDAR. You may have heard the term LiDAR now. I guess in autonomous vehicles, LiDAR is used in lots of applications actually, but it's lasers that scatter off of objects. And in this particular instance, we designed a system that would scatter off of aerosol particles entrained in the atmosphere. So in invisible, tiny little aerosol particles, and we would scatter these laser beams off of them. And the back shift or the back scatter would have a frequency shift from which we could infer velocities. So kind of geeky here, but we could measure the wind with these instruments. Now, why did this plane crash? We had probably the best commercial aviation equipment in the world at Delta Airlines. We probably had one of, if not the best training in the world. At the time, if you had asked somebody, is Delta Airlines a highly reliable organization, I think most people would say yes, they were highly reliable. Again, that's a subjective term that we'll get into a little more deeply here later. But the question becomes, how and why did the plane crash? Well, we know how it crashed because the wind field overcame the aircraft's ability to achieve sufficient thrust. That's easy. Why is a lot harder. Why did the pilots not recognize it? Because they couldn't literally see the wind. Therefore, they didn't take adequate precautions to advance their energy state and spool up and get the airplane positioned for a go-around. So that very simple thought struck me as a young man, that in order to manage a risk of any type, we must see and understand it. We must see and understand it. It's not enough to see a risk. You really have to understand it in order to be able to manage it. So hold that thought, because it becomes very powerful as we move into our model. Now, flash forward about 10 years, where I started working. I went on the break, became a physicist with NASA, did some test pilot work on wind shear recovery, came back to the airline, became the chief safety officer, and along the way, I created a program called ASAP. Now, I don't know if any of you are aviation professionals here, but I'll just give you kind of an overview. This is a chart that's prepared by Boeing that I've added some elements to, and they tracked the rate of improvement of U.S. and Canada commercial aviation safety record from 1959 through present day. Now, along the way, you'll see was a dramatic reduction in the early 1960s of aviation safety. Now, let me just ask this question for any of you that may be aviation professionals or any of you that are enthusiasts. Why do you think the industry got dramatically safer from 1959 to 1966? Can anybody hazard a guess as to what drove that improvement from the early 1959 to about 1966? Can anybody guess?
Well, Scott, while we're waiting for people to venture a guess in the chat box or live, I'll throw a couple out there. I would say some advances in technology and probably more crashes.
Yeah, yeah. Well, the humorous answer is, well, I was born in 1959, so I'd like to take some credit for that.
Nice
Uh,
one.
yeah, so obviously that's illogical for me to say that. But another thing happened in 1959 that I didn't put on this chart, but in 1959 they established the National Transportation Safety Board and the Federal Aviation Administration. So previously there was an entity called the Civil Aeronautics Board, but they bifurcated that into two separate entities, one reporting to Congress and one reporting to the Department of Transportation. So they set up two regulatory bodies to oversee aviation. Now, I mention that because I can tell you that it had virtually no effect on the aviation accident rate. It didn't happen because of regulation. It happened because the industry made a transition from propeller-driven aircraft with lots of moving parts to jet engines, which were incredibly, exponentially more reliable. Fewer engine failures led to fewer crashes. Technology or system design created the first dramatic improvement from 1959. Now, you go all the way back to the Wright brothers in Dayton, Ohio, and say, well, what happened between the time they did their inaugural flight in 1959? Well, a lot of things happened. They started using checklists. They transitioned from World War I fighter pilots into World War II, but all of those were flown with reciprocating engines. Jet engines dramatically improved reliability. Now, there's a lot. That's the first thing I have listed on the bullet here, transition to jet engines. About 1970, we started using simulation. You can imagine how training pilots in emergency conditions in simulators dramatically improved pilot performance. Something called ground proximity warning systems. There's a whole host of improvements. Most of these were technological up until about the mid 1980s, when a term that you're probably familiar with came into prominence, crew resource management, or CRM, right? But from 1959 to about 1985, almost all of the improvements were technological. Now, you mentioned the regulator, or I mentioned the regulator, and we talked about crashes. Crashes or adverse events are the tip of the iceberg. And hold this metaphor. You might ask, Scott, why are you mixing aviation and maritime with an iceberg? And planes don't fly underwater. Well, I'm going to tell you why. Because what we did was, about 1994, we stopped looking at crashes as the dominant way to learn about safety. Now, you may have heard the term black boxes, particularly when you read the news about what happened in China. And I'm not going to speculate about what happened. Have any of you seen the video on that, by the way? There was a security camera video that was released. It appears to be authentic, and that plane is headed straight down. I mean, straight vertically down. Now, I'm not going to speculate for a variety of reasons, one of which is I have good friends at the National Transportation Safety Board, including the past chairman, Robert Sumwalt, and the previous chairman before him, Chris Hart. I'm not going to speculate, but what I will tell you is the black boxes on those airplanes have been recovered and they will be analyzed. Prior to 1994, the way we learned about safety was dominated by investigating adverse outcomes, plane crashes, and even near misses, which, by the way, near misses is a misnomer. I'm going to describe a little bit later why we're more interested in what I call far misses, not the near misses, but the far misses, and I'll explain what I mean by that. But we stopped looking at investigating crashes as the end-all be-all, and we started focusing our attention on systems and human reliability below the surface. We flipped the iceberg. And so the term black box, actually it's a misnomer because the boxes are actually not black. They're international day glow orange. I can tell a story about that, but they're not black, they're orange. And by law, these were prohibited until about the late 1990s. We were prohibited by regulation from reading the black boxes unless the plane had crashed. And I and a group of other industry leaders got together along with the labor associations, and we said, look, waiting until the plane crashes is too late. Rather than waiting to look at an adverse outcome, why don't we look at the data that we can collect before the plane crashes and put in all the assurances of appropriate use, all of the protections that we need to make sure that the data are used correctly? Why can't we look at that and become more predictive around plane crashes? Why can't we intervene before the plane crashes? Now, let me just stop and say, easier said than done, right? Because it's easy to pull a black box and read data. But if you want a human to tell you what happened before the plane crashed, what do you think the likelihood of that is in most instances? Let's play a little game. Dean, I'll play with you, and Bob, if you're on, I'd like you to come on video. I want to play a little game where you guys undoubtedly have car insurance, right? You drive
Yes.
your cars, right? Bob, you have car insurance?
Yeah.
You probably do. I mean, it's a state requirement in most places. So I'm going to play a game where I'm your insurance agent. Okay? So what I'd like you to do, I'll start with you, Dean. Would you call me as your insurance agent when you have a near miss? That is, if you say you're running a yellow light in an intersection, you almost clip another car. Would you just pull over and give me a call and just let me know so that I can document that that happened?
That's probably very unlikely, Scott.
Okay. Bob, if you drive over the speed limit for any reason, or if you talk on the phone, even if you change lanes without signaling, when you get to where you're going safely, would you just keep a record of that and call me so that I can create a profile on you?
First off, Scott, I think you have the wrong number. Okay.
It's not a sales call. Yeah.
Of course, I would not be that proactive. Thank you.
I think the term near miss or close call, I think we overvalue when people will report. When people will report. Now, you probably know, I used to give this example and people were laughing about it and were shocked about it, but you probably know today that with your insurance company, it's very likely you can sign up for a program and get a discount. Either they have little apps on your cell phone. Some of them are more sophisticated where they take data off of your car itself. We have recorders in cars. So, but the question is, from an insurance perspective, which is a better indicator of future performance? Not past, but future. Your history of driving in accidents, or the way you drive every day that we don't typically see? Which is a better predictor of the probability of you having a crash? Well, we clearly proved in aviation that looking at data on the aircraft, the way the aircraft is being flown, and getting information from our pilots, a program called Aviation Safety Action Partnership, which I created. I designed the program. The first program was implemented on June 1st of 1994. Today, there, believe it or not, over 767 ASAP programs. And these ASAP programs are a partnership between the FAA, the Federal Aviation Administration, the labor union or association, and the airline itself. I'll describe that detail because that's going to play into what we call collaborative high reliability. A partnership between regulator, airlines, and unions, which was unheard of in aviation prior to 1994. Pilots are actually self-reporting before a close call or a near miss occurs. They're self-reporting, and we're looking at data continuously on aircraft. We're seeing how the aircraft is being flown, whether it's too fast, too high, or off course, all of those data, and we create a picture of risk long before the plane crash occurs. So that's why I say we flip the iceberg from waiting for the plane to crash and go investigate it to analyzing terabytes of data or more in real time in some cases, or near real time, to identify trends where we can intervene before the plane crashes. So with that in mind, I'm gonna lead us into what we call what I call the sequence of reliability. Okay, this is the sequence of reliability in a nutshell. It's 35 years of my professional life. If you see a flaw in this logic, please tell me now, because I do this presentation over and over, and I want to test it against everyone's experience. Known adverse events are the tip of the iceberg. Reported near misses may also be the tip of the iceberg. An audit or an inspection. Any audit or inspection that we do is a momentary snapshot in time. It's not going to necessarily predict what will happen in the future, although it may be a good source of information, but it's never the complete picture. So the sequence of reliability is this. First, see and understand risk, and then manage sociotechnical reliability in this order: systems, human, and then organization. Systems, humans, and then organization. We got this wrong in aviation. We started with systems. We improved aviation safety. Remember this slide I just showed you? Dramatic decrease, because we were engineers and we knew how to design better aircraft. We didn't know how to design better pilots, but we knew how to make the equipment more reliable. But pilots kept crashing the planes. So we started with systems. Then we started in 1985 focusing on making the human better with crew resource management and simulators and all of those things. And then in 1994, we said, wait a minute, we're not managing all of the risk. We're only training when the plane crashes. So we did it out of sequence. We did systems, human, then we looped back to seeing and understanding. And then finally, in 1998, we started making organizations risk-based rather than rule-based. I'll describe that in just a moment. So we did it out of sequence, but we got amazing results. Going back to this slide here, when we shifted and flipped the iceberg, we achieved a 94% reduction in the fatal accident rate between 1998 and 2008. And I'm proud to say that record has been sustained since that time. Now, does that mean that every airline in the country is highly reliable? No. Does that mean just because the industry has made dramatic improvement that it's highly reliable? No. It means that we achieved a level of success that we've been able to sustain since about 1998. We're still susceptible to failures, and I'll go into why we've created the Just Culture model to go along with this. Because you don't see Just Culture on this list, do you? We didn't really have a Just Culture in aviation at the time these improvements were made. Now I'm going to come back and we're going to touch on all of these, but I want you to hold this in your head. Seeing and understand risk first, managing sociotechnical reliability in this order: systems, human, organization. Let me give you another example. By the way, this sequence applies at the individual level, whether it's me standing on a ladder trying to get the leaves out of my gutter, or something I do driving a car, or a physician or a surgeon operating on a patient inside an operating room. If we don't see and understand the nature of the risks we're trying to manage, nothing we do with our systems, nothing we do with human behavior is going to get us optimal outcomes. Here's an example. In January of 2020, when we started getting reports out of Wuhan, China, that there was this new novel coronavirus that later became designated SARS-CoV-2, the world applied the lesson we learned in 2003. Now, if you're any of you old enough to remember 2003, there was a pre-pandemic known as SARS. SARS was becoming evident out of China as well. I was the chief safety officer at American Airlines. What did we do at American Airlines? We went out and ordered tens of thousands of prescriptions of Tamiflu, which turned out to be only moderately effective. But more importantly, the international security community agreed with the World Health Organization that said, if we take passengers' temperature at the gateway airports, we will eliminate the spread, because anybody that's contagious will have a fever. So on all the Asian gateway airports coming out of China, the security officers would take the passenger's temperature. If you showed a fever, you would be denied boarding. Of course, it's a communist country; they can impose more stringent requirements there, but that was very effective. It's preventing the worldwide spread. So the pandemic truly never rose to the level that we saw with COVID. Flash forward to 2020, and the World Health Organization made the false assumption that SARS-CoV-2 would be infectious in the same manner that SARS was, which turned out not to be the case. So we allowed patients to come out of the Asian gateway airports. They took their temperatures, but guess what? They didn't recognize the propensity of asymptomatic and pre-symptomatic expression. In other words, most studies have shown that up to 80% of patients that contract the virus will become contagious before they show evidence of a fever. We didn't see and understand the nature of that particular novel virus. So everything we did downline, from the systems we put in place, including taking people's temperature, to putting in social distancing of 6 feet, which, as you can imagine, there's nothing magic about the distance of 6 feet or 2 meters. That's a system. To wearing masks, and whether the mask was cloth or an N95 or a KN95 with different levels of reliability associated with it. Nothing we did with those systems was going to get to optimization if we didn't understand the nature of the virus we were trying to prevent. Now you get into beyond systems. And how about the human behaviors in that? Would people actually social distance? Would people wear masks when they were directed to? Could businesses and states and municipalities even enforce codes and regulations around that? And you know the history of, really, it's torn our country apart in some ways, where we've all been divided around this. But from a scientific standpoint, we did it out of sequence. We tried to impose social distancing. We tried to impose certain mask requirements long after the virus had already escaped China, and we weren't able to go in and adequately get to optimization. Now, clearly the vaccinations, the vaccines have been highly effective. You know, this is a huge success story in the annals of medical science, but medical science alone isn't enough to control human behaviors, because we haven't yet achieved the level of vaccinations that we had hoped for. Therefore, it has had dramatic effect on the spread of the virus. Now, I'm not trying to wade into the politics. I'm trying to paint a picture of the science. Seeing and understanding the risk first, understanding system reliability, human reliability, and then finally organizational reliability is the key to getting optimal outcomes. Now, why would organizational reliability come last? The answer to that is very simple. Because organizations are combinations of people working inside systems. People working inside systems. It doesn't matter what organization you work in, you have systems, you have people. You will have turnover in those people. You will have equipment that will degrade and be replaced. As technology improves, we hope that reliability improves. As people turn over, what happens? You have to refresh their understanding of the risk that they're seeing. So this connective tissue, if you will, between systems and human is something that we're going to explore in the model. All right, I'm going to pick up the pace here because we have about 39 minutes left and I want to leave time. Do we have any questions so far, Dean, that people have asked? I see 24 chats. I don't know if those were recent or if they occurred earlier.
There were some that sprinkled in throughout, Scott. No outright questions, but a lot of interesting comments about do we call things near hits versus near misses, for example, Tanya brought up. So there's just been some interesting commentary as you've been going.
Yeah. I prefer the term near hit. You know, I also prefer the George Carlin term. He said as a passenger, he doesn't want to get on a nonstop airplane. He wants to land when he gets on the plane. Which I found to be quite humorous. I actually met George Carlin one time. I stepped out of the cockpit. I was the captain, and he's standing in front of the lavatory. This was before 9/11, and had a nice conversation with him. So, so a few ways an organization sees risk. You can see accident investigations, audits, surveys, rounding, inspections, customer and external reports. These are things that I consider to be above the waterline. As you see, here's a list of things that we typically would use that are more sophisticated in trying to see below the surface. And I just want to make a point here about employee reporting systems. In aviation, the employee reporting systems that we started were called event reporting systems. And the words we use often matter. Event implies that something has already happened and has crossed a threshold. So if I go back to my game that I played with Dean and Bob about the insurance, it being their automobile insurance agent, if I had called that an event reporting system, they wouldn't have reported anything because no event, no crash had occurred. So take the nurse in Vanderbilt 2 years ago that went to a medication dispensing cabinet. She puts in the name of a drug in a digital format. The drug that pops up is the wrong drug because she only typed in the first two letters of the drug's name. She overrode it because the drug that popped up was a paralytic, which means it can paralyze you. She looked at it briefly and said, no, this is the drug I want. Don't keep me from it. She overrode it. She took the med to bedside. She administered it. It was the wrong medication and it killed the patient. Now, that was obviously an event. It's a terrible story, horrible and tragic for the patient. She was fired. The nursing board is taking her license and she's being criminally prosecuted for negligent homicide. Now, the question is, if we punish human behavior, whether it's human error and human choices combined, what does that do to our ability to collect information? Now, say I'm a nurse in that same facility on that same day, and I pull up a drug, I override it, it gives it to me. It's the wrong drug because I overrode it. I go to a patient's bedside, and just by circumstance, I decide to do a triple check, and I look at it one more time, and it's the wrong drug. And I say, oh my gosh, I could have killed a patient. And I run back to the dispensing cabinet and I put it back. Am I likely to report that? It's an open question. It's a hypothetical. I know a nurse got fired, her license taken away, and she's criminally prosecuted. I may think multiple times before I decide if I'm going to report that. We want to create a just culture environment where we report risk, not just events. So I'm going to make a pitch here that we don't want to call our reporting systems event reports. We want to call them risk reports. And I'm going to show you why we believe it to be just culture to be important. I'm going to go through this very quickly because I want to get into the conversation about how we audit to the model. So systems have multiple influences. I don't have time to go into all of these in detail, but you can take a look at this. And if any of you have engineering backgrounds, you'll recognize there's a lot of influences that affect the way systems perform. Clearly, the way humans operate the technology or the machinery, whether the system has exceeded capacity. If you look at healthcare as an operational system, in many places during the pandemic, the load exceeded the capacity. Therefore, the care that we were able to give was less reliable in many ways than it would have been had we had a lower load. You can see these features here all affect system reliability. What we want to be able to do is predict where systems may fail and manage them accordingly. Now, to do that, we have to understand a basic principle of reliability, which is reliable systems have two features or two characteristics. They are effective in doing what they're designed to do, and they are resilient when things go wrong. Effective and resilient, two separate features. So let's take the efficacy of a mask that I wear to protect myself against the SARS-CoV-2 virus. If I'm wearing a bandana mask, we can actually go in, and by the way, this is physics more so than medicine. We can do an analysis on how effective that cloth bandana is at preventing the virus from penetrating into my mouth, or nasal cavities. So we can assign an effectiveness to that mask, correct? All right, so you may know the term respirator or N95. Many of you that are maybe occupational safety and health professionals will know an N95 is pretty much the gold standard in occupational health and safety. So an N95 is going to be more effective, isn't it, at preventing, say I'm a healthcare worker in the early days of the pandemic. If I have an N95 that's been fit tested for my face, it's going to be a more effective barrier than a cloth bandana or even a surgical mask. Would you agree? Dean, I'll look to you. Would you agree that an N95 would be more effective? Now, if that N95, due to short supply on the second month of the pandemic, and I have to reuse it over and over and over again because we've run out of capacity or inventory, that effectiveness may degrade. Or if I take the mask off incorrectly by grabbing, instead of taking it off by the straps, holding it like this and putting it inside a secure container, if I take it off with my hands and touch it on the outside, my bare hands, and then I rub my eye, so is that barrier, which may be 95% effective in rough terms, is it resilient to human behavior? If the strap breaks, the single point of failure for an N95 may be the way the strap is fused to the cloth itself or to the material itself. If the strap breaks, is that 95% effective mask still reliable? No. So it may not be resilient to human behavior or mechanical failure. So if reliability is much more than just how often does it stay up, is it effective when it works right? And most systems are not 100% effective even when they work correctly. And how resilient is it when things go wrong? All right, now to do that, engineers know there are features called barriers, redundancies, recoveries. We combine those strategies in cumulative ways to provide what the engineering people would call defense in depth, or how we build system effectiveness and resiliency. Those are features that we have to understand. Okay, so I told a story some time ago. I'll retell it today. It's another healthcare story. A patient in a cardiac ward in a Boston hospital about 12 years ago died. And what happened was the cardiac patient at bedside, an alarm starts sounding. A nurse walking down the hall hears the alarm. And oh, by the way, in healthcare, they have something that we call alarm fatigue, where there's so many alarms that they're very commonly overridden or silenced because there's too many alarms going on at once. This nurse goes to the bedside. She wasn't sure which device was sounding, so by process of elimination, she turned off one device after another, off and on, to see if she could stop the alarm. She went to the cardiac monitor. She turned it off. The alarm kept sounding. She finally found it was an infusion pump, which pumps medication in intravenously. It had become occluded. She reset it, stopped the occlusion, turned it back on. The alarm went away. Problem solved. She went back to the hallway to go treat other patients, but she forgot to turn the cardiac monitor back on that she had first turned off. Human error, right? So she goes down the hallway. Sometime later, the cardiac patient, went into cardiac arrest and died, and no one on the floor knew because the cardiac monitor alarm did not sound. The Joint Commission came in and did a big investigation. The Boston Globe got wind of this. The Boston Globe sat down with the patient safety officer, one of our clients, Greg Meyer. He was the chief safety officer at the time at this hospital. And they interviewed him, and the Boston Globe reporter said, ask a series of questions, and ended with this question: have you fired the nurse who caused the patient's death? And Dr. Meyer said, no, because we don't consider that to be the right response. Now, we could, but what we see is this is a combination of a system, a patient, and a caregiver, that's called a sociotechnical system. If we fire the human who is closest to the scene of the impact, what chance do we have of other nurses reporting the same behavior or the same human errors? So at my urging, Dr. Meyer went back to the manufacturer of the cardiac monitor alarm and asked a very simple question. He said, can you redesign this cardiac monitor such that if someone turns it off and it is working properly, if it's functioning properly, and someone turns it off either by mistake or with intention, that it can reboot itself and come back on? And what do you think the engineers said? Of course, we didn't know you wanted us to do that. Engineers actually don't think like real humans, do they? Sometimes engineers are very geeky. They don't understand why us humans don't operate the machinery or the equipment the way it was designed. So the engineers, not thinking like a nurse, said, why would you turn it off? They didn't anticipate the human fallibility in the equation. So was that cardiac monitor alarm highly reliable? No, it was effective when it was turned on and connected to the patient. It was not resilient when a nurse turns it off, either with intention or by human error. Again, we have to look at systems differently. We have to not think of them solely in terms of how they perform mechanically or electromechanically or digitally. We have to learn how they perform in combination with the people that are actually operating the equipment. All right, so now we're going to jump into human reliability, and now we're going to move into what we consider the just culture approach. And I'm going to describe that in just a second. As you can tell, systems impact the way humans perform, personal factors impact culture, knowledge, skills, abilities, behavior, all of this stuff that you've heard many times before. But in this model, we're going to understand that we can predict where, if not when, humans can fail. Think about that statement. We can sit down and anticipate all the ways that people will take shortcuts, make human errors, make risky choices, even be reckless. We can anticipate that, and we can work to manage the system they're in, and we can work to manage them as human beings. And I'm going to show you how we do that. Now, let's consider some of the factors influencing human reliability. The factors on the left-hand column are what we would consider to be system factors. Training, environment, distraction, stress, fatigue. All of these can be system related. And on the right-hand side are examples of personal performance shaping factors. So there's no doubt that fatigue plays a role in human performance in any job, whether you're a pilot, a surgeon, a nuclear plant operator, any endeavor that you see. If humans are involved, if I'm fatigued or burned out or stressed or have distractions, I may not be performing at peak performance. Now, you see these arrows here. Distraction, stress, fatigue, and burnout in culture can arise either in the system or in the personal life, or sometimes both. So in aviation, we have stringent requirements for length of time on duty and how many hours a pilot can fly in a given time period. All of that's well and good. But if I go home off duty with adequate time to rest, and for whatever reason I can't sleep, maybe I took Dayquil instead of NyQuil, or maybe I was in a hotel and they assigned me a room next to an elevator and it went off all night long, or people were partying. It doesn't matter how good the regulation is, if I bring that personal performance factor into the workplace, I may not perform at peak performance. So we're going to make a distinction between something called performance and behaviors. Now, if our HR colleagues were with us, they'll be very familiar with these terms. There's something called performance management, which involves knowledge, skills, abilities, how the system influences us, the personal influences, cultural influences, perceptions of risk, and competing priorities. Before we can address behaviors, which will come in two categories, the choices we make and the errors we make. Choices and errors. Before we can manage behaviors, I want to convince you we have to pay attention to performance, because it makes no sense to address my errors and choices if you don't understand the influences around me. So we have to be able to see it, again, in a sequence. Performance management should come before behavior management, which, by the way, the just culture approach that has been in place for years started with behaviors, and I was a big part of that. I was one of the co-authors and contributors of the original just culture algorithms and approaches. And I want to share with you that we have evolved this model beyond starting with human behavior. If something bad happens or we see a risk, if we start with human behavior and we don't understand the risk and the systems and the performance shaping factors, nothing we do with that human is going to be optimal in terms of the results we get. Now, in a classic just culture environment, there's a distinction made between human error, at-risk choice, and reckless choice. Now, I'm not going to go into that because the purpose of this conversation here is to move us beyond the traditional just culture model. I'm going to assume that most of you are familiar with these terms, and as you know, in a just culture, we typically don't punish people for human errors. We only punish them when those errors become reckless or repetitive, and I'll describe that, a little more detail. So, organizational reliability combines systems and people. Systems and people. You see that here. System reliability, human reliability. We can manage these factors to higher reliability. Yeah, this is just a really quick little provocative discussion. I'm not a big fan of the term links in a chain, because you've all heard the expression accidents are links in a chain, which imply that all you have to do to prevent an accident is remove one link. And by that model, all links are equal. As long as you break the chain, it doesn't matter. You've stopped the event from happening. That's rarely the way things really happen, and I'll explain that in just a second. Jim Reason came up with this in 1995, which I'm a big fan of Jim Reason's, but I have to tell you, even Jim says, look, don't take the Swiss cheese model too seriously. It's just a metaphor. I would say to you, if the world is filled with holes in Swiss cheese, what's the solution? And the only answer is, well, you fill the holes in the cheese. And I would say, yeah, but what if you can't see all the holes in the cheese? But by the way, you're going to run out of money and resources before you plug all the holes in the cheese. And when I mentioned that to Jim one time, he said, yeah, don't take it too seriously. But every damn conference I've been to with safety professionals in my life since 1995, people put this up. It's holes in Swiss cheese. The problem with holes in Swiss cheese, again, is when an accident happens, it's only one way that you can penetrate those barriers in the cheese. I'm going to show you a better way to look at it in just a second. I'm not a big fan of root cause either, because root cause it implies that the singular seed from which everything flourishes or everything propagates. So we make a joke sometimes that all root causes can be traced back to bad parenting. The truth of the matter is that root cause sets us up mentally to think that all we got to do is get to that root cause. Now, most of you are, I'm sure, sophisticated enough to use the term root causes in the plural, and that's a much better way to see it. We're going to show you a different model, which is based on Boolean logic and these fault trees that can be built. And this is combinations of system breakdowns and human activities that can be combined into mathematical pathways to failure. I don't have time to do this. Perhaps at another time, Dean, we can do another webinar on that. But you can model virtually any sociotechnical activity, and you can address this through a more sophisticated methodology than simply an FMEA or an RCA. So I'm going to jump past this now and show you the model itself. Now, I'm going to ask a question of you. I'm going to just take one moment here. And the answer to this should be obvious, but it's something that it's good to reflect on. Highly reliable organizations must be good at A, seeing and understanding risk, B, managing systems, C, managing people, and D, sustaining organizational improvement. Now, the obvious answer here is E, all of the above in sequence. Now, what I would ask you to ask yourself introspectively is, where do you put your focus in the job that you do? Where do you put your focus? If you're a behavioral scientist, you're going to focus on managing people. If you think like an engineer, you're going to be looking at managing systems. If you work with reporting systems and audits, you're going to look at seeing and understanding risk. And if you're a leader in the organization, you're going to think about, well, how do we keep our organization improving? All of those have to come together. HR, managing people, the engineers, managing systems, the safety people, seeing, understanding, auditing, the business leaders trying to guide the organization, all of you, that has to come together. And now I'm going to show you the model itself. What are the attributes of a highly reliable organization? Now, I ran out of time because I had a family emergency last night. I actually was called in. I went to see my daughter. She's okay, but we called an ambulance, and they came in and they checked her out, and she was fine. I was racing to get here in time, and I just barely made the presentation. Now, she's fine. She's well taken care of. She's doing great. It was nothing clinical to be worried about. But in the healthcare environment, I would ask you, what makes a highly reliable hospital? What makes a hospital highly reliable? Now, you don't have to be a healthcare professional to answer this question. You can just be a patient and answer this question. It's a hypothetical. What makes a hospital highly reliable? Well, I'll throw out a couple of things. Would you say safety is important? Safety of patients, employees, and visitors? Now, go back to the aviation example, and I showed you that dramatic improvement in aviation safety. What I was talking about was plane crashes. We achieved a 94% reduction in plane crashes. I didn't tell you that the OSHA recordable injury rate in that industry during that same time period was exceedingly high. I didn't tell you that our ground damage rate of equipment on the ramp, the tugs and the little trailers that drive around carrying bags, had an atrocious rate of damage on our ramp. I only told you about the plane crash statistic. To be highly reliable as an airline, you must not only pay attention to preventing the plane from crashing, but you must prevent your employees from being injured. You must prevent your passengers from catching COVID. You must manage your equipment appropriately. So safety involves more than just the end result of a nuclear plant meltdown or a catastrophic plane crash. Safety involves occupational safety and health, protection of assets. It's more than just patients and customers. Would you also say that privacy is important to you as a healthcare patient? If you go in and they breach your patient privacy or your financial records, would you be upset with that hospital? Would you then, if you had a choice, would you perhaps take your healthcare needs to another facility if you had an option? Equity is a really important value. If you're a member of a community that is lower on the socioeconomic scale, or you're a minority of any type, and you receive less health care than someone else that walks in that maybe has more money, or their skin color is of a different color, or their nationality, or the way they speak the language, would that upset you? And would you consider the hospital that attends to you highly reliable? We think not. If they don't treat you with respect, if they walk in and the doctor is like, I don't know, there was a TV show a few years ago called Dr. House, where he was this brilliant physician, but he was a real jerk. If a doctor insulted you or didn't pay attention to what you were saying, but did a great job with you clinically, would you say that's a highly reliable physician? Probably not. All of these attributes come to play when we look at healthcare or energy or transportation or manufacturing. today, with what's going on in this terrible, terrible tragedy in Ukraine, we know that there's President Biden. This is not confidential information. President Biden has put the nation on alert for cyber attacks. There could be bad guys coming out trying to harm our power systems, our transportation systems, our healthcare systems. So if you're what you consider to be a highly reliable hospital, but somebody comes in and has a ransomware attack on your hospital and shuts all your systems down, you're not going to be able to take care of the same number of patients at the same level of performance. And by the way, do you think hospitals are experts in IT security? No, hospitals are experts in medicine. Hospitals are experts in the science of medicine. There's another science, an engineering science, in the delivery of care, and there's another science yet in the science of cybersecurity. Those involve multiple disciplinary approaches. So to be highly reliable in any capacity, we have to think beyond just the traditional measures that we've used. So we're going to define reliability with these certain attributes. And we're going to also talk about what is quality and what makes quality an element of high reliability. So organizational reliability is an umbrella for quality, safety, risk management, operations, finances, and human resources. Now, I'm throwing a lot of words out here. Now, many of you may be familiar. I suspect that most of you are familiar with quality management principles. Let me just ask you a question, and it's a rhetorical question, but I'll look at Dean's face to see what the answer is. If you are an organization that has become ISO 9001 certified or registered, does that guarantee that you are a highly reliable organization?
I'll say no on that one, Scott.
That's right. That's right. And so I see we have 38 chats that have built up. I hope the answer, because I can't see your chats, I hope the answer that most of you are saying is no. But, and there's a but here, it's an important but. I call this, in mathematical terms, a necessary but not sufficient condition. In order to become highly reliable, you must engage in quality management principles. And I'm going to spout out what some of those are. And for those of you that are ISO qualified and registered, bear with me. I'm going to scale this to a lay terminology. The philosophy that Edwards Deming created, years ago in Japan was document, monitor, and measure. Document what you do, say what you do, and do what you say. Document, monitor, measure, continuously improve. So an ISO expert that comes in is a process expert. ISO experts aren't going to go into your industry and tell you how to keep the plane from crashing. They're not going to go in and tell you how to keep the plant from melting down. They're not going to go in and look at the grid and say, here's how you fix the grid to ensure reliability. They're going to go in and look at what you're doing in terms of your quality control features. And there's a difference between quality control and quality assurance. That's for another webinar. But quality management principles involve looking at it from a document, monitor, measure, continuously improve. That doesn't necessarily, in and of itself, get you to high reliability. What we believe, and this is the essence of our model, that you have to get the big rocks in the jar first to become a highly reliable organization. What are those big rocks? You've all heard this analogy about the big rocks. It's gone around, on the internet for years. There's TED Talks on it. The professor goes into a class and he shows a jar that's filled to the top with big rocks. And he asks the students, is the jar full? And most of the students say, yeah, the jar is full. And he comes in and he drops in a whole bunch of other little pebbles that make their way into the jar. So now you've got a jar full of big rocks and small pebbles. And he asks the class, is it full now? And the class says, yeah, it looks full. And he comes in and he brings a bag of sand and he pours sand that pulls in underneath between the pebbles and the rocks. And he says, is it full now? And by now people are catching on and say, some say yes, some say no. And he takes a pitcher of water and he pours the water in. And now the jar is filled with big rocks, pebbles, sand, and water. Well, the lesson, of course, of that little story is if you want to get the big rocks in the jar, you got to put them in first. So what are the big rocks in high reliability? You must have a collaborative, we'll call it collaborative, a just culture program and a core group of individuals that we will call a reliability management team. Because no organization can get to high reliability without consultants or with consultants alone. So we're going to explain what that means. So we have created a model that DNV comes in and audits, and they have two qualifications that are achieved first. So it's a stair-stepped process where you achieve a just culture program. Now, you may not have been used to hearing the term just culture as a program. And I'm going to just take 30 seconds and ask you, can anyone on this call define just culture? Can you define it for me? I see 40 chats. Does any of those chats offer a definition for what just culture is?
None of them do, Scott. So I'm just pausing here to see if anybody wants to raise a hand and just offer a definition or chat it into the chat box, because I'm confident there are at least one or two out there that want to give it a shot.
In 1998, a colleague of mine and I sat down at Fuddruckers and we wrote an algorithm on a napkin that became the just culture algorithm that has been replaced by our methodology, which is a little different, that focuses on the sequence of reliability. But over the years, I've been involved with just culture for the majority of my career. I taught organizations for 15 years just culture, and I started my own company because I became frustrated that we couldn't define just culture, we couldn't document, monitor, and measure it at the organization level. I taught tens of thousands of individuals just culture, and every one of them, I believe, gained something from it. But it was a philosophy, not something that could be documented, monitored, and measured. We created a program based on the ASAP model that can be documented, monitored, and measured. And if you look here, I'll just give you a little preview of what you might see next month when DNV does their webinar. The elements of a Just Culture program include executive leadership and governing body support. You have to have written statements from your board and your C-suite that show the commitment behind that. You have to have labor associations involved. You have to have policies that govern the program. You have to train people up to a level of proficiency, and you must use tools that can be replicated so that one person using the tool can use the same methodology, and there must be a sustainment plan in it. Now, I'm not going to give you more details because I'm going to hold that for DNV's webinar. You must achieve a level of auditable performance, and that audit has to be time-based, because you can have a just culture and meet all these requirements today, and 2 years from now, turnover and the organization takes a different course or direction, and you might not have the same environment, the same culture. So the program can be defined, it can be monitored and measured. Now, along with that comes accreditation is a basic foundation that every organization must have. You won't get to high reliability without being accredited if you're in a regulated industry. You must be accredited first. Then the team and the program can be audited at a qualification level. And there are 3 levels of organization certification that I will hold off until next week. Now, the final evidence here the final information that's evidence-based is it's not enough to have an algorithm walking around, managers using it individually, because individual managers have different levels of proficiency and reliability. The ASAP model in aviation was based on a unanimous consensus model involving a triad. Now, in aviation, it was a regulator, a labor union, and the airline. In our collaborative high reliability model that we use Just Culture, we use a management representative, HR, and a safety, quality, or risk representative. And using the same methodology of ASAP, that team together uses a tool that looks at risk, systems, human performance, including all the performance shaping factors, human behavior, and then the organizational response. That has to be documented, monitored, and measured. It must be aligned and integrated. That way, an organization can say, before we take action with an employee that results in discipline or even termination of employment, before we come in and make a significant system change, we must run this through a process. So it's not enough to just have a tool or an algorithm. You must have proficiently trained individuals working as a team in a process using a tool. That can be documented, monitored, and measured. Within a Just Culture and within a reliability management team, we have different roles that individuals will play. They are audited to that standard, and they must have a certain level of training to proficiency. So I'll end with this slide and take any final questions. And I can stay over longer, but I know I will end it at the top of the hour for those of you that have other commitments. We created a very simple taxonomy of terms, and this is all contained in the DNV requirements. Now, I know that different industries use different terms, but I went in and looked across multiple industries and said there are activities that take place that we do lots of things inside an organization that may or may not be documented, and I will just call those activities. They may be good to do, they may be here today and gone tomorrow, but they may be pervasive in your organization. There are other things that you do that are more formal, and we'll call those processes that should have some level of documentation, like a checklist or a procedure or even a policy. There are programs like ASAP and others that become higher order, that a program produces an output. Programs produce a result. They are combinations of processes and other components that must be aligned. Whether it's a Lean Six Sigma or an RCA, they must be aligned within the program. There are systems that are combinations of programs, policies, procedures, and other components. And then there are integrated systems that must be aligned. And I will ask you this. In your organization, when something bad happens, we typically see separate siloed investigations by HR, looking at what to do with the employee, safety, quality, and risk. And then you may have operational investigations. In a collaborative high reliability organization, all of those must be aligned and integrated at a level that can be audited. And that's the essence of what happens when we go and look at the things that you're doing inside your organization. We ask ourselves, which category does each activity fall into? Seeing and understanding risk, managing your systems, managing your people, or managing organization. And you can collect that into a structure that can then be audited together. And the key to this is being able to document, monitor, and measure, and then ultimately aligned and integrated into what we call a reliability management system. So we have put definition into what a highly reliable organization does. We call it the big rocks in our jar, and we believe that organizations won't get to high reliability without those big rocks. And we think that doing so requires independent assessment and qualification. Because if you're not able to have someone else come in and do this, then you're working against the principles of high reliability. So if any organization is actually hiring consultant companies that come in and teach them to be highly reliable, and then they audit you around that, what they've taught you, they're right there in opposition to the principles of high reliability, which is those that teach you how to perform should not be the ones that check you or examine you for that performance. So I apologize for taking you 2 minutes over. I will stop. I told you that you'd have to pull a hook in at me at the end, Dean. I'm going to stop here. I can stay on as long as anybody wants, but I'll be happy to take any questions or comments.
Well, Scott, thank you so much for all of that. So while we're pausing to see if there are any questions that people want to raise their hands or unmute themselves or chat them into the chat box, we do have one in the chat box that I'll give to you.
Okay.
Do you have any suggestions on how one team and one company in a fairly traditional, even punitive industry can begin to evolve toward the HRO vision you described without getting shut down by compliance-based bosses, lawyers, regulators, et cetera?
Yeah, I absolutely can. I mean, it takes a village, and what you do is you build a coalition. One of the first steps is go to your HR leaders and say, look, you approach employment this way, we approach it this way. Let's come together and recognize that we shouldn't be siloed. We should be aligned. We'll be different organization. And then that group goes to the next group of operational leaders, get some allies, and then go together before your C-suite and say, let's have a conversation. Because your CEO, once they see this beyond just safety and compliance, and they start to see the competitive advantages, all the things we put up on that first slide, the preservation of assets, improvements to the bottom line. Now you get their attention. When you convince the CFO, ears perk up. And so all of it's connected because you're all hoping to do the right thing, but they need a strategy that shows how you can get there. And having that qualification from an independent body is worth something. It's worth more than just a plaque on a wall. It's worth everybody pulling toward a direction to achieve that level of certification.
Awesome. And while we're waiting for any more questions, first off, Scott, thank you so much for sharing the story about your daughter, and I'm glad she's okay. And apologies. I sent Scott a text 5 minutes before we started, just asking if he was all set for today. And Scott, not knowing that background, I really appreciate you more than ever. And I'm glad she's okay. And Scott, if it's okay with you, I'll ask everybody who would like the hidden science to just let me know, put that into the chat box. If you're interested, everybody, please put your email address into the chat box. Scott, I'll pull all those out and send those on to you. Is that all right?
That's perfect. Perfect.
And while we're waiting for any more questions, what I'm going to do is I will put a post-webinar survey into the chat box. And I'm also going to include the link to the upcoming conference that we're having in June, where you'll see more of Scott. So for those of you who haven't registered yet or considered it, the link is going to be in the chat box, and perfect opportunity for you to click that link and find out more.
Let me give a shameless plug for the conference, Dean.
Yep.
That first morning, I understand that I'm going to be presenting alongside Todd Conklin's going to speak, and Mike Barger's going to come in and speak. Two friends of mine. You want to see them? They're much better than I am at presenting. But Todd, especially, last time we had the conference, I'm sitting there at the cocktail party in the evening after I'd had a couple of drinks. Wasn't driving, and Todd's over there with his microphone, and he says, "Hey, you want to do a webcast or a podcast?" And I said, "Sure." It's the only time in my life I've ever sat down and done a podcast having had 2 beers. So just want you to say, Todd's entertaining. His presentation along with Mike is going to flow nicely with mine. So I highly urge you to come to the conference if you can. It's going to be well worth your time.
Yeah, thank you, Scott. And I totally agree that the first day and all of the content is just going to be a great opportunity to learn and collaborate with colleagues from different industries. So it's just going to be it'll be very worthwhile. So with that, we're over time. Everybody feel free to leave if you need to for other commitments. Thank you, as always, everybody, for taking your time, Scott, particularly to you for just sharing your insights, sharing your time with everybody. And for anybody that wants to stay on and ask any questions, please feel free to stay on. But otherwise, have a great rest of your day and take care.